Hello. Okay, so we're going to start Unit 8. So Unit 8 covers quadratics. So starting with 8a, this is just attributes of quadratic functions, and we're going to actually graph these parabolas. So just a heads up, full disclosure, this might be a bit of a long lesson, and it's going to be a lot of information thrown at you kind of all at once. So just forewarned. So starting off, quadratic functions refer to equations in the form of f of x equals ax squared plus bx plus c. So we've actually seen these equations when we were factoring in Unit 7. So we're actually looking more in depth at these equations. So whenever we were saying factor these quadratics, that's actually the name of those equations. So when we graph these quadratic equations, they produce a graph and they produce a curve that we are going to call a parabola. So that's really what the graphs are called. All right, so we're looking here at the parent function. So remember, the parent function is the original graph with no transformations. So there's no vertical shift, there's no horizontal shift, there's no stretch, there's no shrink or compression, there's no reflection. It's just the original graph that was produced. So here we have our quadratic parent function of just y equals x squared. So just FYI, remember back when we did function notation, y is the same thing as f of x. So you could see this written as f of x equals x squared or y equals x squared. They're interchangeable, and depending on the problems that we're looking at, we could be doing both. So if you're ever wondering why the heck we're going back and forth between y and f of x, it really just depends on, nope, do not erase that. Come back. It really just depends on the problem that we're doing. So just kind of some structure for you. If I expand standard form, or no, if I expand the parent function into standard form, we only have this very first part because the b and the c values, that should not be a c, that should be a 0. So if I expand the parent function into standard form, this is what it really looks like. So just some information for you, some background. All right, so as mentioned before, we have the standard form, which is ax squared plus bx plus c, and the graph name is called a parabola. So when referring to the domain and range, remember the domain is going to refer to how far left and right it goes. And then the range is going to refer to how far up and down it goes. All right, so the domain, so I already have the graph over here. So if I'm looking at how far left and right it goes, it's actually going to be all real numbers. It's never going to stop going to the left. It's never going to stop going to the right. If this line will work, thank you. So because of these arrows up here, it's never going to stop going to the left. It's forever and ever going to go to the left. And then ideally, or not ideally, same idea for the right. It's never going to stop going to the right. So even though it's going to go off the graph, it will continuously go to the left and the right, which means the domain here is going to be all real numbers. All right, which is already written there for you. So remember, you could expect to see the symbol for all real numbers, or you could actually see all real numbers written out. It's not going to matter which one. Both are going to be fully accepted. All right, now for the range, keep in mind the range actually is going to have a limitation or a restriction on it. So the range is always going to be limited by the vertex. Which we will talk about what a vertex is here in a little bit. So notice how it dips down all the way down here to 0, and it equals 0, so it's a closed circle. So that's at 0. And then it goes all the way up indefinitely. So it never stops going up. So our range here is going to be y greater than or equal to 0. So that's kind of where the range comes from. All right. So now we're going to kind of get into some vocab. So full disclosure again, you're not going to succeed in Unit 8 or Unit 9 when we deal with quadratics if you do not know your vocabulary here. It is crucial. It is imperative. It is So important to know your vocabulary for these units. So the vertex of a parabola is the highest or the lowest point in a parabola. So that little dip over here, where it kind of curves, this point right here, that's the lowest point, which means that is my vertex. Okay. Now remember, your vertex can be either your highest point or it can be your lowest point. So if it meets at the bottom, that's going to be your lowest point. But if it meets at the top, that's going to be your highest point. So your vertex is either or. All right. Now your axis of symmetry, or abbreviated, it's called the AOS, because writing out axis of symmetry 20,000 times gets annoying, so I abbreviate it. So the axis of symmetry, or the AOS, is the vertical and dashed line. So emphasis on vertical and dashed. All right. And it always passes through the vertex. So let's do this little drawing right here so you can kind of see. Let's see if this will work. All right, so I just kind of roughly went over this graph. All right, now I want to draw a vertical dashed line. So your AOS and your parabola, the AOS, that vertical dashed line, will always pass through the vertex. So if your parabola moves, that axis of symmetry is also going to move. It's always going to pass through the vertex, no matter where your parabola is. Okay. All right. And now referring to a minimum and maximum, respectively, it is the lowest and highest point of the actual parabola itself. So as you can see, they're color coded here, just like on the key. So if it is a minimum, that means the vertex meets at the bottom. But if it's going to be a maximum, that means it's going to meet at the top. It's the highest point. So the vertex at the top is a maximum, vertex at the bottom, which is your lowest point, which is a minimum. All right, and then we're looking at the solutions. So really the vocab term here is solutions, but I actually kind of gave it to you. So the solution of a quadratic function is where the parabola crosses the x-axis. So it's where your y value is equal to 0. So kind of think back to when we did linear equations. Linear equations, we were really heavily focusing on the y-axis and like the y-intercepts. Now with quadratics, we're kind of shifting that focus. Now instead of focusing on the y-axis, now we're going to focus on the x-axis. All right. So now kind of looking down here, we have the parent function again, but now we're going to kind of look at the different parts and look at the different components. All right. So over here, written in red, are kind of some notes for you guys to keep in mind, like how it's written or how you find it. All right, so looking over here at the parent function, so we have everything already labeled for us, or if it's not, then it should be. Yikes. So if it's not written, pause here, take a minute, write in these values here, and then we're going to go over to the left side and we're going to fill in the rest of it. So for your vertex, it is, in this case, the lowest point. So it is written as a coordinate, which is, in this case, 0, 0. So over here, your vertex, which is written as a coordinate, in this case, it is 0, 0. Now your vertex is always written as a coordinate. All right, so now we want to find the axis of symmetry. So I will say this, typically we're going to find the axis of symmetry first, and then we use the axis of symmetry to find the vertex. So it's really just this one problem where we're doing it backwards. So keep in mind your axis of symmetry, it's a vertical and dashed line. Now think back to when we did Hoy-Bucks. If it's a vertical line, that means we're going to be using bucks, which means because it's using bucks, we're going to be using an x equals equation. So your AOS is always going to be written as x equals. So just keep that in mind. All right, so I'm going to go over back to my graph, and I see my AOS is written here, my axis of symmetry. It's the vertical dashed line that's written right down the middle. So you could also look at the x value of your vertex. That's what your AOS is going to be. So in this case, it's x equals 0. So over here, your axis of symmetry is x equals 0. All right. So now we want to determine if it's going to have a minimum or a maximum. So keep in mind, because our parabola faces up, it means our a value is going to be positive. So that's what's written over here. Now, if our a value is negative, if we have a negative in the very front, that means it's going to face down, which means it's going to have a maximum. So in this case, looking at the parent function here, I'm going to refer back up to the top right here. So see how we have an a value of 1 right here? It's a positive 1, which means it's going to face up. And because it faces up, that means we have a minimum. It means at the bottom. So right here, if you're on paper, you can circle, or if you're on your iPad or some digital tablet, then you can highlight. Either one are acceptable. All right. So now for your solutions. So we're going to get a lot more in depth in solutions when we get to Unit 9. So Unit 8 is really kind of the attributes of quadratics, whereas Unit 9 is actually solving them. But we're just going to kind of briefly talk about the solutions here. So the solutions are, we're looking at the x values, or you can write them as an x equals, or you can write it as a coordinate. But what we're really focusing on is where it crosses the x-axis. That is the imperative part here. So it either crosses or it touches. So in this case, looking here, it crosses the x-axis at 0. So right here, that solution, that's what we want. So in this case, your solution is just going to be written as x equals 0. Now keep in mind, all of these are like 0 values, but that's because we're looking at the parent function. The parent function is kind of the bare bones skeletal structure of what we're looking at. So when we start looking at more problems that have like vertical shifts or horizontal shifts or stretches or shrinks or compressions or reflections or anything like that, then that's when the values are going to start actually becoming more apparent. All right. So what we want to do first before we start actually graphing and finding these attributes, we want to be able to ensure that we're good with finding ABC values. We have to be able to find those, otherwise you're kind of doomed from the get-go. All right, so we want to identify these ABC values based on our standard form equations. So we're looking at just the coefficients. We're not really concerned with the x squared or the x values. We just want to know the coefficient, which is the number in the front. All right, so looking at this very first one over here. All right, so we have f of x equals x squared plus 5x minus 6. So we don't have a number written in the front here. So because of that, we assume there is a 1 written. So to prevent me from going back and forth on the screen and making you guys dizzy and making myself dizzy, I'm just going to kind of write them underneath. And then you guys can fill them in on the side. Or if you want to do the same thing I'm doing, you go for it. All right, so we're going to have an a value of 1, b value of 5. And because we're subtracting that 6 at the very end, we have a c value of negative 6. All right, so looking at the one below. So notice how we have that negative, but no number. So once again, we're going to assume that there is a 1 there. So because of that, we have an a value of negative 1, a b value of negative 2, and we have a c value of positive 1. All right, so far so good. Hopefully no one's crying or having a breakdown. Just me. All right, anyways. So moving on. So we have y equals 4x squared minus 9. So notice how this one only has 2 terms, whereas standard form has 3. So that means we're missing one of these terms. So notice how we don't have an x value. So I'm going to rewrite this as 4x squared plus 0x minus 9. So now you can probably see what the actual ABC values are. So you have to pay attention here because this gets people every time. So your a value here is 4, your b value here is 0, and your c value here is negative 9. So looking at this last one here, same idea, except instead of missing the b term, now we're missing the c term. So in this case, your a value is negative 2, b value is positive 5, and a c value of 0. All right, so if you want to fill in those ABC values over here, if you haven't already, you can, or if you want to leave it like how it is over there, you can. It's up to you. All right, so kind of looking more at the quadratic side of it, or nope, rewind. So kind of looking at the solution side of quadratics, we want to determine how many solutions we can actually have. So kind of think of it. Our parabola is kind of a cup shape or a U-ish shape. That means it has two opportunities to cross the x-axis, which means you can have up to two solutions. All right, so I'm going to color code this here. So because we can have up to two solutions, so I'll do the first one in blue. So two solutions is going to be if it crosses the x-axis twice, 2 times. So it could face up, it could face down. It just means it crosses it twice at some point. So for example, I'll say this. So if you press and hold your pen here on your iPad or digital device, hopefully on Notability, you go down and actually do a parabolic shape and hold it. Notability will actually auto-generate that parabola for you. And you will have those markers or the identification points where you can actually maneuver and move those points. So I can move the vertex if I wanted to, or I could move one of these other parts, but just cool little trick for you. All right, so this parabola crosses our x-axis twice, which means we have two solutions. Ooh, forgot my arrows. All right. Now, for the next one, let's say we only have one solution. So what that means is our parabola is only going to cross the x-axis one time, exactly one time. Now, what that means is the vertex has to be on the x-axis. So I'll draw it going down this time. All right, so draw my arrows. So notice how the vertex here touches kind of the x-axis. So that means that we only have one solution in this case. All right, now keep in mind your parabola may not intersect your x-axis at all. So if it doesn't even touch the x-axis, that means there's no real solution. Now, emphasis on a very specific word here. The fact that we are saying no real solution. Because when you get to algebra 2, you can actually find imaginary solutions, and you can find these complex solutions using radicals that involve negatives. We're not doing that right now. We're going to save that for your algebra 2 teacher. Right now, not our problem. So right now, all we're just going to say is no real solution. So in red, that means your parabola just does not cross the x-axis at all. So there's just no solution. All right. So we want to actually be able to plot these parabolas on our graphs by hand, but you can also use your Casio calculator or your TI calculator or whatever graphing calculator you have. So I included here these steps on how to do it by hand. So we're actually going to do a few problems by hand. So for this first one, you guys probably will not have this on your graph, but I left the parabola on there. So we're going to go ahead and find these attributes given the parabola. And then we're going to start from scratch and we'll just do the bare bones. All right, so starting off, this is what your practice problems are going to look like. So first off, you want to identify your A, B, and C values. So looking over here at your equation, we have f of x equals x squared minus 4x minus 5. So once again, you're going to have an A value of 1, a B value of negative 4, and a C value of negative 5. So I'm going to go over here, A value of 1, B value of negative 4, C value of negative 5. All right, so I want to identify my AOS, my axis of symmetry. So that is the vertical and dashed line that you're going to see on your parabolas. So over here, with my graph already drawn, I just want to find what that line's going to be. So my AOS is this dashed purple line right here. So that point right here is at 2, 0, which means my AOS is going to be at x equals 2. So over here, I know my AOS is x equals 2. All right, now I want to find the vertex. Now remember, the vertex is going to be either the minimum or the maximum of your parabola. So down here, this point in orange, this is going to be the vertex. So the vertex, that coordinate is, let's see if I can count, 2, -9. All right, so that's what I want to write for the vertex. So now I want to determine if this is going to be a minimum or a maximum. Now see how it faces up, which means it's going to meet at the bottom, which means this is going to be a minimum. So over here, it's a minimum. So what I'm going to do to kind of give my graph some more detail, I'm actually going to go over here to the vertex, and in parentheses, I'm going to write the minimum, because the minimum or maximum describes the vertex. So I want to put as much information on my graph as possible. All right, now I want to look at the rest of these attributes. I want to find the domain and range. So your domain of your parabolas here are always going to be all real numbers. So you can really just draw the symbol. That's not an R. I don't know what I'm doing. I'm going to attempt to draw this. Oh my gosh. Close enough. So I'm going to draw the symbol for all real numbers, which is my domain. And now I want to look at the range. So remember, the range is kind of the tricky one. So you have to look at the y value of the vertex. All right, so this is going to be written in regards to y. And the y value of my vertex over here, I'm looking at -9. So I know that's going to be my value in the range. All right, so I want to write y in -9. That's a weird looking 9. Everything's fine. All right, so now you want to determine, is it going to be less than or equal to or greater than or equal to? So just, let me do this. Boom. All right, so if you want your values less than, that means your vertex is going to be a max. However, if we have a minimum, we want all the values that are bigger than that value. So because we have a minimum, we want all the values greater than -9. All right. So I'm going to get rid of the maximum part. What I'm going to do is, because we have a minimum, we want all the values greater than -9. And then -9 refers to the y value of the vertex. Y value of vertex. I write English very well, I promise. Everything's fine. All right. So now we want to write the solutions of our parabola, of our quadratic equation. So remember, we're looking to see where it crosses the x-axis. So just as a review, or as a reminder, that's not a highlighter. Great job. This is our x-axis right here. So we are looking to see where it crosses that x-axis specifically. So we're looking at this point and this point. So just a reminder, we can have up to 2 different solutions. All right, so I want to be able to write these either as just independent x values, or I can write them as actual coordinates. All right, so that solution over here on the left, we have -1, 0. And then the solution over here on the right is going to be 5, 0. So that's what I want to write for my solution. All right, so over here, you have the option of writing either x equals 2, 5 with no parentheses, or you could write it as 2, wait a second. That's not right. Rewind. Just kidding. buffering. All right, so we want the solutions -1, 0, and 5, 0. Math is really hard. Nope. So x equals -1, 5. So don't write this in parentheses, because if you write it in parentheses, then you're writing it as a coordinate, which is not what we want. But if you do want to write them as coordinates, then you could say -1, 0 and 5, 0. So it's really up to you. I will say it's mostly going to be written like this, just as the independent x values. So just know either of those are accepted. It does not matter which one. All right, so keep in mind, this is if your graph is given that you can do this. Now, keep in mind, your graph is not always going to be given, so you may have to start from scratch, bare bones. All right, so we're going to start this problem just from square one. Alrighty, so I will say this is probably your more important problem, just because we're starting everything from scratch. All right, so we want to start by finding our ABC values. So you have an A value of -1, we have a B value of 10, and we have a C value of -21. So you can write those over there if you want. All right, so here's the thing. We don't have our graph. How the heck are we going to find the axis of symmetry? I'm glad you asked. So there's actually a formula for you. So to find the AOS, if you're just given the equation, it's x equals the opposite of b over 2 times, over 2 times your A value. All right, so what I'm going to do is I'm going to go back up to my ABC values, and I'm going to kind of fill in those gaps. So I want the opposite of b. So what I'm going to do is I want the opposite of my b value, and then I want to do 2 times my A value. Now I want to simplify. All right, so that means I'm going to have -10 over a -2, which simplifies to a +5. All right, so what that means is your AOS is x equals, why can I not draw a 5? There we go. All right, so this part right here is super important. That's gray, close enough. That's how you're going to find your AOS. All right, so now we want to be able to find the vertex. Actually, before that, let's go ahead and plot our AOS. So it is my vertical dashed line, and it's going to be at x equals 5. All right, so at 5, I'm going to draw a vertical dashed line. So I'm going to do all of this literally step by step. All right, so we know the vertex has to be on the AOS. So their vertex is going to be a point on that vertical line. All right, so now in order to find where that vertex is going to be, what I want to do is I'm going to take that AOS value. So I'm going to take this 5, and I want to plug it in for x to actually find that value. So what that means is I want to find, there we go. I want to find f of 5. So what I'm going to do is for every x value in my equation up here, I'm going to plug in that 5. All right, so I'm going to have -5 squared plus 10 times 5 minus 21. All right, so right here, these 5s, that's what I'm plugging in, and that's what I want to find the value of. All right, so to find that value, let's start simplifying. So I have -5 squared, which is 25, then 10 times 5, which gives you 50, and minus 21. So this means we're going to have a -25 plus 50 minus 21, and that is going to be equal to 4. All right, so that means my vertex is going to be written as a coordinate. So keep in mind, we're taking the x value from our AOS, which is 5, which means this is going to be my x value of the vertex. And we just found this 4, which is going to be the y value of that vertex. All right, so I'm going to plot a point at 5, 4. So over here, I'm going to use orange. I'm going to put an orange point right here on my grid. So that's my vertex. All right, so the next part is we want to identify if it's a minimum or a maximum. So look at your A value. Our A value is negative. So because our A value is negative, that means we have a maximum. I cannot spell. We'll just leave it at that. My brain's not working. All right, so we have a maximum. So just a disclaimer, if A was positive, that means we would have a minimum. All right, so now we're looking at the domain. Domain should be your easiest question on any assessment for quadratics because it is always auto numbers. That's a funny looking auto numbers, but it's fine. All right, now we're looking at the range. So remember, your range is the one that has its restrictions. So it's going to be y in regards to the y value of our vertex, so 4. All right, and then because it is a maximum, we want everything below. So keep in mind, because it's a maximum, we want everything below the vertex. So that means we want less than or equal to 4. So that's going to be our range. All right, now we want to find the solutions. Now to find the solutions, we kind of have to finish our parabola over here to the right. So we got to finish graphing it. All right, so here's kind of the trick to graphing these by hand. I'm going to make a table. Now you want to find some very specific points, not just any arbitrary points. So what I'm going to do is I'm going to start with my vertex. So what I mean by that is I'm going to take 5, 4, and I'm going to put it on my table right here. So I know this right here is my vertex. So I want to find at least a good 3 to 5 points after my vertex, which means the next x values I want to use are going to be 6, 7, 8, and 9. So we want to be able to plot all these points. All right, so what you want to do is you want to take those x values and you want to plug them in to your original graph up here. All right, so I want to plug in -6 squared plus 10x minus 21. So that's not right. Oh, duh. Plug in 6. There we go. All right, so when I plug it in, you get a value of 3. So that's what I'm going to write for the corresponding y value. All right, so it's going to be 6, 3. And now you want to do the same thing, but now you want to plug in 7. All right, so when I plug in 7, you get 0. So you have an option. You can either calculate these values by hand or you can use a calculator. It's up to you. I would definitely recommend using a calculator just because it'll save you a crap ton of time. Some of these problems are already going to take you a hot minute. All right, so same idea. Now I'm going to plug in 8. So if I plug in 8, hello, there we go. You get -5. All right, then I'm going to plug in 9. So when I plug in 9, you're going to get -12. All right, so these are all the points that I want to plot on my graph. Now keep in mind, all these grids that I give you are going to be a 10 by 10. So this point right here is not going to be griddable. We can't graph that one. So we want to plot all the other points. So I'm going to go ahead and graph 6, 3. It's going to be right here. So there's 6, 3. Now I want to plot 7, 0, which is right here. And then I want to plot 8, -5, which is right here. So if you kind of look, you can see we have about half the parabola. Now, if you're probably wondering how the heck am I going to get the other half? We only found those points. Glad you asked. So if you look here, we have an axis of symmetry for a reason. What I'm going to do is I want to essentially reflect those points over my AOS. So given this half of the parabola, I'm going to reflect them over my AOS so I can get the other half. So in order to do that, this first point here is 1 square on the right. So now I'm going to go 1 square to the left. And I want to get the other half. So the same idea here. This point is 2 squares to the right. To get the other, I want to go 2 squares to the left. And there's that point. And now this point here is 3 points to the right. Now I want to go 3 points to the left. All right, and there's our parabola. So now you just want to draw the shape. All right, so your parabola here, I will say drawing parabolas is going to be a little difficult at first. So press and hold if you're on your iPad. Then you want to adjust it to make sure it passes through all your points. So there's the parabola. Nope. Let's do this. There you go. All right, so we're looking to find the solutions. So we want to find where it's going to cross the x-axis. So it's going to cross at this point and this point. So those coordinates, respectively, are 3, 0 and 7, 0, if I can count. All right, so that's what I want to write over here for the solutions. So x equals 3, 7. So just remember, if you write 3, 7, that is wrong. It's not a coordinate. We're writing the independent x values. All right, so this is what your practice problems are really going to be like, just FYI. I should probably do this on a Casio. Where's my Casio? Okay, please hold. Okay. So the calculator that I used earlier was a TI-84, but now I'm actually going to use the Casios. All right, it's the same functionality and whatnot. All right, so now we're going to do the next one. So we have f of x equals 4x squared plus 1. All right, so notice how this is a 2-term quadratic equation, so we're missing one of our terms. So in this case, your a value is 4, your b value is 0, and your c value is 1. So this could be rewritten as 4x squared plus 0x plus 1. So we're missing our 0x term. All right. All right, so we want to find our axis of symmetry. So remember, your axis of symmetry formula is going to be x equals the opposite of b over 2a. All right, so for this first one, I want the opposite of 0 all over 2 times my a value of 4. Now, if you take the opposite of nothing, or 0, you still have nothing. So 2 times 4, which gives you 8. Now, if you have 0 over a number, that gives you 0, which means your AOS here is x equals 0. All right, so now I want to find the vertex. So I'm going to plug in that x value from the AOS. So I want to find f of 0. All right, so I want 4 times that value squared plus 1. So we're plugging in that 0. All right, So when you do that, let's see if I can actually type. So you can even do this on the calculator and you get 1. All right. So keep in mind, you can do these by hand or you can solve these on the calculator. It's really up to you. Some of these I will say may be quicker by hand. Some of them will be quicker on a calculator. All right, so 4 times 0 squared, which is 0, plus 1. Anything times 0 is 0, plus 1, which gives you 1, which means your vertex is 0, 1. All right, so I'm going to look back at my A value. And notice how our A value is positive 4. So remember, if your A value is positive, that means it's going to face up, which means when it faces up, that means it meets at the bottom, and that means we have a minimum. All right, domain, all real numbers, as always. It's always forever going to be going left and right. Now your range, remember, these are the boogers. So we want y in regards to the y value of the vertex, which we found was 1. And then you're going to use the minimum or maximum to kind of help you. So remember, if it's a minimum, that means we're going to want all the values above it. But if it's a maximum, that means we want all the values below it. So because we have a minimum, I want this one. I want everything bigger than, or nope, I want everything greater than or equal to 1. All right, and now for the solutions, this is where I need to actually draw my parabola. So I'm going to use these attributes and go ahead and start drawing. All right, so I'm going to draw my AOS first, which is my vertical and dashed line, which is going to be at 0. So it's going to be my, that's horrible. It's going to be my, on top of the y-axis. All right, and now I'm going to plot my vertex, which is at 0, 1. So now I need to find my other table values. So this is where I'm going to draw my table. I'm going to try to. There we go. So remember, we're starting with the vertex. So I'm going to start with 0, 1. And then afterwards, then you want to find the other values. So after 0, you can find 1, 2, and 3. So we'll just say 3 values for this one. All right, so just like before, you're going to take your equation and you're going to plug in those respective x values. So if I plug in 1, hello, let's see if you can see it. You're going to get 5. So if I plug in 2, you're going to get 17. And if I plug in 3, you get 37. All right, so notice how, because we're on a 10 by 10, 2 of these points are not going to be able to be graphed. All right, so we can only graph one other point. So I'm going to plot a point at 1, 5. All right, and then I want to find the other side, so I'm going to reflect it over the x-axis. And then you want to draw your parabola. Wow, that is truly awful. Close enough-ish. Oh my God. All right. So there's that. All right, so there's our parabola. So notice how this parabola does not cross the x-axis. So what does that mean in terms of solutions? Well, it means we have no real solution. So your solution here is simply just no real solution. So remember, whenever you're writing a no real solution, you cannot just say no solution. You have to be you have to be very explicit and say no real solution. So please remember that point.